So that 4, you can actually bring that out to the front. Okay, so you have e to the 6t to the 5th times t to the 4th with respect to t. Okay. Oh, forgot my respect to t. Okay. Now, there's two ways you can do this one. You can divide both sides by 30 if you wanted to. You can do it that way. Or you can just multiply this by 30 and divide by 30 out here. You'll get the exact same thing. Okay, so that means our du over 30 is equal to t to the 4th dt. Oh. All right, so that means here you have 4 e to the 6th t to the 5th, that's our e to the u. T to the 4th dt, that's du over 30. And we can just bring that 30 right out to the front. Okay, so you have 4 over 30, integral of e to the u du. Okay, so that becomes 2 over 15 if you want to just simplify that one now. Oh, 2 over 15. Times e to the u plus c. So we just plug back in our u. E to the 6t to the 5th plus c. All right, and that would be your final answer. Okay. I'm doing a lot of examples because there are so many different forms this can actually take. It's still a lot of them that you probably still aren't seeing today. So I'm trying to do as many as possible to show you how to approach them. All right, so any questions on this one? All right. Okay, so let's say, for example, we wanted to... Move it up. Oh, sorry about that. Evaluate the integral of negative 7x e to the 5x squared. Oh, respect x.
Square root of x squared. No, it's 5x squared.
Oh, yeah.
Oh, it's 5.
Yeah.
Okay.
All right, I'll give you a minute to start on this one. Remember, if you get stuck, just raise your hand and let me know. I'll be right over. Alright, so for this one, we can get that -7 and bring it right out to the front if we wanted to. But first, we're going to let u equal 5x squared. Okay, so the derivative of u is going to equal 10x with respect to x. Or you can just go ahead and divide both sides by 10. So du over 10 is equal to x dx. Okay, so if we got that -7 and just took it right out to the front, you have e to the 5x squared, and just move the x dx there. So we have our e to the u. And you have our du over 10. Okay, so that's -7 times the integral of e to the u times du over 10. We can just get that 10 and just bring it right out to the front. So you have -7 over 10. The integral of e to the u du, which just becomes -7 over 10 e to the u plus c, which is -7 over 10 e to the 5x squared plus c. All right, any questions on this one? No, okay. Make sure you're still writing. Yep. Okay. So the next integral formula, as far as exponentials go, is the integral of a to the power of u du equals a to the u over natural log of a plus c, and that's where a is just a constant. And this one's pretty straightforward. It's mostly just a matter of remembering the formula and plugging stuff in. Okay. Let's say if we wanted to evaluate 2 to the integral of 2 to the x with respect to x from 0 to 5. Okay, so in this case, integral from 2 to the x dx, your a is equal to. Okay, so from 0 to 5. So we know the integral of 2 to the x dx is going to equal 2 to the x over natural log of 2. And we don't need the plus c because it's definite, so that's from 0 to 5. Okay. And natural log of 2 is a constant, so if you want it, you can go ahead and factor that right on out. So 1 over natural log of 2, so that's 2 to the x from 0 to 5. Then we use our fundamental theorem. So 1 over natural log of 2, 2 to the 5th power minus 2 to the 0 power. Okay, so you end up with 1 over natural log of 2 times 32 minus 1, which is 31. Or you can write it as 31 over natural log of 2. Any questions on that one? All right, so let's do another example of this one. I'll leave that up for a few seconds. Okay. All right, so what if we tried the example we wanted to evaluate from 0 to 1, 2 to the x plus 1 with respect to x. Okay, so you don't have the x exponent, so you're going to have to use the u version of it. So we let u equal x plus 1. So your derivative of u is going to equal 1 dx or dx. Okay, so that means your integral from 0 to 1, 2 to the u, and your dx is du, is going to equal 2 to the u over natural log of 2 from 0 to 1. Okay, so since those x equals 0 and x equal 1, we just convert that back to a function of x. So 2 to the x plus 1. And that natural log of 2, since that's a constant, we can go ahead and factor that out. So 1 over natural log of 2 from 0 to 1. Okay, so using the fundamental theorem, you have 2 to the 1 plus 1, which is 2 squared, minus 2 to the 0 plus 1, which is 2 to the first. So you end up with 1 over natural log of 2 times 4 minus 2, which is just 2. Plug that into your calculator, and you'll end up with 2.885, give or take. Okay. And this one's pretty straightforward because you're pretty much just plugging it right on in. For most of these, the hardest part will be figuring out where your u is. All right, so any questions on this one? All right, So let's do one more. Okay, so we wanted to evaluate the integral of 2 to the power of 3x minus 1 with respect to x. Now I'll give you a minute or two to start on this one. Okay, so for this one, we're going to start off by letting our u equal 3x minus 1. Okay, so derivative of u is going to equal 3 with respect to x. Or divide both sides, our dx equals du over 3. Okay, so we have our integral of 2 to the u du over 3. Make that a little bit smaller. Just bring that 1/3 right out to the front. Two to the u du, which is going to equal 1/3. I don't know why I put 1/2 there. Times 2 to the u over natural log of 2. Just plug back in your u. Two to the 3x minus 1 over natural log of 2, or you can just combine them together. 2 to the 3x minus 1 over 3 natural log of 2. Oh, plus c. All right, so any questions on this one? Yes.
You
you have natural log of 8 on the bottom.
Where you get natural log of 8?
The one of the log rule.
Oh,
The exponent, the power.
using the power rule for
Yeah.
three natural.
Oh,
numbers.
okay, I see what you're saying. Oh, yeah, you could have put it that way if you wanted to. So, or 2, 3x minus 1 over natural log of 2 cubed plus c, which could have made that 2 to the 3x minus 1 over natural log of 8 plus c. Okay, so you have a couple of different ways you could write it. Let's see. Either way would be correct. Okay. Any other questions on this one? All right. Okay, so we have one more formula. Okay, so the integral of log of base a of u with respect to u is equal to u times natural log of u minus 1 all over natural log of a plus c. And again, with this one, it's just a matter of plugging in values. So let's say, for example, if you wanted to evaluate the integral of natural log, not natural log, wrong one, of log base 6. Of x minus 1 plus c.
Do you mean dx?
No,
Instead of plus
I'm
six?
jumping ahead to the end. Yep, dx. Thank you. All right, so here, you know your a is equal to 6, and our u is equal to x minus 1. Which means our du is just going to equal dx. Derivative of u is equal to 1 dx, or just dx. Okay, so the integral of log base 6 of u du is going to equal your u, which is, you can just leave that as u for now, natural log of u minus 1 over natural log of a, in this case, 6. Okay, now we just plug in our u values and plus c. Okay, so we have x minus 1 times the natural log of x minus 1 minus 1 all over natural log of 6 plus c. And if you wanted to, you could FOIL method and all that other stuff, but you don't have to. That one's actually good enough there. All right, any questions on this one? All right.
Question.
Sure.
Should that be factored out at all?
Which one?
This
This one?
The final answer?
You can if you want to. You can do FOIL method and x natural log of x minus 1, but you don't have to.
Okay.
All right. Okay, so let's do one more of these. Oh, bring that up a little bit. So if we wanted to evaluate the integral of 11 log base 14 t with respect to t. So with this one, first thing I had to do is just bring the 11 right on out to the front. Oops, straighten that out a little bit. Okay, so log base 14. Oh, clean that up a little. Of t with respect to t. Okay, so we know that your a is equal to 14. Your u is just t, and your du is dt, so you don't have to really do too much there. So that's 11 times your x. Well, in this case, you can just use x instead of not x, t. So t times natural log of t minus 1 all over natural log of 14. Or you can write it as
Plus C.
plus c. Or you can write it as 11t over natural log of 14 times the natural log of t minus 1. Either one will work. Plus c. As you can tell, I do not take off too many points for missing plus c's because I have been doing it for years. So I'm not a stickler about it. All right. So any questions on this one? All right. Okay, so we actually made it through. Oh, make sure everyone's done writing. All right. All right, so was one other, actually a couple other, but I think I'll stick with one other example here that I wanted to do. And this was going, I just wanted to make sure I got through everything, but we're going back to the natural log of u examples. Okay, so what if we wanted to integrate 1 to 2, 20x plus 10x to the third over 4x squared plus x to the fourth with respect to x. Okay. The reason I want to make sure we got this one in is because it's a little bit of a trick on one part of it. Okay. So we want our du over u. So we'll let u equal 4x squared plus x to the fourth. Okay, which means our derivative of u is going to be 8x plus 4x to the third dx.